Hello, welcome, beautiful people. You are welcome to another edition of Automation Quick Fix. Here today, I'm going to be walking you through how to quickly wire up a PLC module. How you can quickly wire up a PLC module. Here I have some PLC modules here with me. I have here a Siemens logo. This is a compact PLC module. It's compact because it has you can see the power supply, the inputs and the outputs on just this single module. This is an S71211C PLC. It's also a compact module. This is another compact module PLC, and it has the input and IOs with the CPU all together on this module. This is another PLC. This is a modular PLC. This is the CPU and this is the input. You see they are separate, and there always a means of connecting both of them with the backplane connector. You can connect both the other modules together. This is a modular PLC. So I'm going to take one of these PLCs and quickly walk you through how to wire them. The first thing you want to do is, when you want to wire a PLC, you would want to know what that PLC really is. You want to consult the PLC manual and then find out some things about the PLC. So here, I said earlier, this is a modular PLC, and if you look at the terminals very well, you can see already what is expected here, 24 volts. Here, the PLC will be giving out 24 volts here, and of course, the inputs that are expected to be coming to the PLC are 24 volts input. This PLC also has analog inputs here, and then these are the outputs. It has 4 outputs. Yeah, those are relay terminals, relay outputs. So we are going to head on quickly to the manufacturer manual of this PLC. We can also have a quick look at the spec written on the PLC body. So this is what we are expecting: power supply of 24 volts. The PLC can take 0.9 amps, and then that's the digital input, 6 digital inputs. It has 4 digital outputs, and it can also take 2 analog inputs of 0 to 10 volts. So here I followed the PLC part number, and I could seek for help from the Siemens support site. And then this is the diagram for wiring the PLC. So here I'm expected to wire a 24 volts to this point. Then I'm supposed to earth here. See, from my power supply, I'm supposed to earth here. And then the PLC will have already 24 volts from these terminals. This is the positive, this is the negative terminal. I'll have already 24 volts here. And then the PLC is actually going to be syncing. This is a syncing terminal. So what I'm expected to have here should be the load, whatever is coming, a switch, a sensor, is supposed to be sourcing, so that the load at the input sources and the PLC will sync the current that comes to it to complete the circuit. And then here, equally, my analog input is going to, the analog inputs are going to be sourcing to the PLC. The PLC will be syncing those inputs. For this particular PLC, I'm supposed to give it an input of 0 to 10 volts for the analog input for the analog devices. And then here, so from the diagram here, this output for this PLC is actually a relay output. So what this means is that once the conditions inside the program conditions inside the PLC are met, the relays here are just going to switch. So between this contact and this contact, there's just going to be a switch and a closed circuit. It's going to close to the other one if the conditions that are going to turn on this other terminal are met, and so on for the 4 terminals. But when wiring, of course the positive is definitely going to come here to the live, and then the negative are going to come to each of the other output terminals. So quite simply, this is what the wiring looks like. I've got 220 volts coming here from the power supply to the input of this power pack, and then from the output of the power pack, that's the 24 volts DC. I've got it coming through the connector straight to the PLC input power supply. Okay, so now I've actually wired one input to this. Like I said earlier, for this terminal, the PLC is syncing, and the input, whatever it is, I'm using a push button switch here, a start push button. When I press, you can see the PLC is seeing the input. So when I press, the current actually flows from this terminal here, from this terminal, all through the switch, and then it gets back in here. So that's the wiring. The current flows from here through here and gets back in here. So the PLC is syncing the current, and my load here, the input, is sourcing the current. So I've written a little program here to test what I've done. So this is my input. This is where my push button is coming from. So this is what senses the push button, and then this is my output. This is a latch to keep this guy on. Since I have a push button now, I will need to latch it so that once with just a trigger, is going to stay permanently on. So let's get this downloaded to the PLC and see if it's going to work. Simulation, no. Real tech. I was trying to go online. I did not connect my Ethernet cable. So let me get it connected. Okay. The PLC is sensing it now. So I tried download again. Okay. Start search. Okay. You can see the PLC now. Then I'll just load the program. Compiles, AR, and load it. Okay, then I go online. Alright, you can see for right now, even though right now the PLC is ready and it's just waiting for the signal. So I come here and I press the start push button, and the output here latches. So I don't need to press the start push button again. The output here latches, and I can see it so far. If I put my PLC on monitor, yeah, I can see that. So the PLC actually sees the start push button. I'm going to press the start push button now, and this tag for the start push button, I0.0, is going to turn green. Yeah, that's the tag, turns green. If I release the push button, the tag goes out. Okay, if I press it, the tag turns green. I release it, the tag goes out. So the next thing now is, how does the relay output terminal works for this model? How does it work? So I've just gone back and have deactivated the input and have deactivated the output. So right now the PLC is not triggered. So I will just go ahead and test these terminals with my multimeter. It is on continuity, okay? On continuity, you see none of the terminals are closed. They are all open. These are all normally open terminals. But once I proceed with the trigger, these two terminals are going to read. These two terminals are going to close. Okay, so I press the push button. You can see right now currently it's not triggered yet. So I'll press the push button. Here the PLC sees it and the output is triggered. We can see that too here in the program. And then I'm just going to read the terminals here. And you can hear my multimeter beep. So the circuit is closed now. So to wire this, you just the output here can actually take anything. From here we can see that it can take like 24 volts DC, and it can take up to 24. It can take up to 250 volts AC. So these terminals are just going to act like a switch: close, open, close, open. That's it. So basically your positive is going to come through here, and it flows back here to your output device, and then from the output device it goes back to your neutral. So I have some small samples of output devices here. It could be this, like a valve. So you just wire it up, Yeah, you just wire it up through this. And this is another one. This is another mag valve that can also be wired up. So I will take it again. Basically, the supply comes through here. The relay closes the contact, and the supply passes through the closed contact, flows back to your output device, and from the output device it goes back to your neutral. Thank you. That will be all for today. Remember to like and subscribe to be abreast of other automation quick tips and fixes as they roll out. Thank you.